Okay, one more example. We're going to do the exact same thing. So for part A and B, we're going to do the same thing. Use our f inverse to prove it has the first derivative to prove that f has an inverse. And then part B, find the slope of the tangent line at a given point on f inverse. So here's your function, and here's your given point on f inverse. Go ahead and try your hand at this. Okay, just to do a check on that, the first thing I did with f of x is rewrote it with the negative exponent, and then take the first derivative here, and then I moved the negative exponent down to the bottom. This is clearly a positive value, so it's going to be greater than 0. Simply just means it's increasing, continuous and increasing, so the f inverse exists. Okay, so the next step we want to do is part B, is find the slope of the tangent line at the point 3, 1 on f inverse of x. Okay, so I write this is part B. Write my formula down, my given information, I pull my first derivative from the previous page. So first thing I'm going to do is evaluate this when x is 3. So it's going to be the derivative of the function when x is 3. So it would be f prime f inverse of 3. Okay, now to calculate this, go to your f inverse when x is 3. What's the y value? It's just going to be 1. So it's going to be 1 f inverse of 1. Now this says go to your your first derivative function, and everywhere there's a x, plug in a 1. So I'm going to write my first derivative function down. So it's going to be, my 1 is just my numerator. Now in red, I'll plug in my first derivative, put in a parenthesis everywhere that there's an x. And then now, because I'm going to evaluate it when x is 1, I'll plug in a 1. And then just simplify this. This is just going to give us 1 to the 4th is 1. That's just going to be a 20. And that's just going to be 3 divided by 1, which is just 3. So simplifies to 1 over 23. Which that's the slope of the tangent line at the point P 3, 1 on the first on f inverse.